Hey, welcome to the study guide for this trimester. All right, for these problems, the very first thing that you're going to want to do is write out the oxidation numbers. That's the first step. So I'm going to go ahead and write those down because I know it's been a while since we've done these. So oxidation numbers, got to write those down first. So tin is in its natural state, so it's 0. Oxygen is also 0. Tin oxide is an ionic compound, so the charges in the oxidation numbers are going to be the same. So oxygen's -2 and tin is +2. The second thing that you're going to want to do is write down oil rig, because oxidation is lost, reduction is gained. So who's losing electrons? Who's gaining electrons? Well, I'm going to start with oxidation. I usually start with reduction, but this time for some reason I started with oxidation. And tin is the one who's losing electrons. It went from a 0 to a +2 charge. I've lost an electron. Are you positive? Yep, tin became positive. So in this case, it lost 2 electrons to have a +2 charge. Now we're going to do the reduction half. Now remember, reduction is gain of electrons, so we write the electrons as reactants in reduction. See, it all starts with the R, reactants, reduction. Well, since we have 2 oxygens, here it shows 2 oxygens, so each oxygen has to has to gain 2 electrons. But because I have 2 oxygens, that means each one of them, and that's a total of 4 electrons. Well, in order to add these up, the electrons have to be the same, and clearly they're not. I've got 4 in the reduction half reaction, I've got 2 on the other. How do we fix it? Well, we're going to multiply the oxidation half times 2. Multiply everything times 2. Now we're ready to add these up because the 4 electrons will cancel. So I'm going to bring down everything that I need to bring down. Now remember, you have a hint for this compound is here, which means you can just bring it down. But we have to have 2 ions, so we needed 2 ions here. And now you're done. I already have the addition bar in there. I'm not going to go back and change it. We'll just live with it for now. So the first thing you need to do is go through and write out the oxidation numbers. Aluminum's in its natural state, 0. Oxygen, 0. Aluminum there is an ion, so +3, and oxygen's -2. Well, then I like to write down oil rig. Whose charge went down? Who was reduced? Well, in this case, it's the aluminum that gets reduced because its charge goes down. And the oxygen is oxidized because it lost electrons. Well, if you lose electrons, you're going to write those as products. But see, if you notice, though, there's a small problem. We have 3 ions here and only 2 atoms here. So if I put a 3 here, that shows 3 ions. But I can't have a 3 here. That's awkward. So what should we do? How about we change it to a 6? Because now I can put a 3 and I have 6 oxygens on both sides. So 6 oxygen ions, each one of them lost 2 electrons for a total of 12 electrons. Now we can do the reduction half. And remember, when we're on the reduction half, we're going to write the electrons as reactants. And that's a total of 3 electrons. However, we do have 2 electrons, 2 aluminums on that side. So we have to change everything by 2. But I don't have electrons here and here that cancel. So I'm going to go ahead and multiply this half reaction times 2. Now they can cancel out. I'm going to start with this guy and write it down. This says I have 4 ions, so if I put a 2 in front of that, I end up with 4 aluminum ions and 6 oxygen ions, which works. There was a 4 here and a 3 here and we are done. William, these next several set of problems, you simply have to identify the reactions listed. All of these will have two answers. Two answers. Make sure you know that there's two answers for all of these. Well, this reaction is a synthesis. Now, it's a decomposition reaction because you have one thing broken down into its individual elements. That's the definition of a decomp reaction. And all decomposition reactions are also redox reactions. This reaction is a combustion reaction. It has oxygen. You got to burn in the presence of oxygen. It's a carbon-based substance, so we end up with carbon dioxide and water. And all combustion reactions are also redox reactions. I know this equation is different than the one in your study guide, so you need to make that change. Make sure you change the equation to reflect the one I have here. I like this one better. Sorry about that. The papers were already printed when I saw it. That's my excuse. Anyway, what kind of reaction is this? Well, it is synthesis. You have one product and it's being made from its elements. Well, that's a redox reaction. Note, all four of these are redox reactions. Again, we have a reaction with a carbon-based substance burned in oxygen, giving carbon dioxide and water. So that's a combustion reaction. Now you do have extra credit points if you can recall what the name of this particular combustion reaction is called. And yes, it's also a redox reaction. Taking a look at this one, I can see it's double displacement because the anions were swapped. Sodium's now hooked up with nitrate. Silver is now hooked up with chlorine. And you should know that it's a precipitation reaction. If you look at your solubility rules, silver chloride is insoluble. And yes, it's a double displacement reaction. I know that I skipped number 9. There is no number 9. Don't worry about it. The numbers still agree with the numbers on your study guide. Take a minute, read through this problem, try it on your own, see if you can do it, and then push play again. Always write down what you have under the equation, and then write down where you're going. It'll help you make a plan. This is a mole-to-mole reaction, one step. You start with what's given. You're going to chase this unit down. The 3 comes from the balanced chemical equation. There's a 3's right there. We're converting to moles of aluminum bromide. Make sure your sig figs are correct, and that's all there was to this problem. Recall that a good idea is to write down what you have under each one of the substances. So we have 3 moles of ammonia, well, 3.5 moles. And what we're trying to solve for is how many molecules. Well, again, we're going to start with what's given. And don't forget, we need to chase this unit down. And I'm trying to convert from moles of this to, well, not to molecules. I can't do that. I'm going to have to get to moles. That's the connector between one substance and another. You have to go through moles. So that's 4 moles. Oh, sorry. We're actually after this one. Moles. There we go. And those 4's come from the balanced chemical equation. Now don't forget, we got to chase that unit down. And 1 mole of anything equals Avogadro's number of molecules. For those of you who don't remember, and you should, it's 6.022 times 10 to the 23rd. Know that number. Make sure your sig figs are correct, and you're done. This is one of my favorite test questions, so be prepared for it. It'll be there. Again, start with what you have underneath each of the substances. All right? But the identity, how on earth are we going to find the identity of X? Well, a good way to do that is molar mass. For example, if I said to you, who has a molar mass of 22.99 grams per mole? Well, easy. You look at the periodic table, you find it's sodium. So if you can find the grams per mole of X, you can figure out who X is. And look, we have grammage right there. What we don't have is the moles of X. But we have moles of this. So can we get from moles of this guy to moles of this guy? Well, sure, it's one step. What are we going to do with this information now? We're going to kind of plug it into there. So you end up with 175 grams of X divided by 14.58 moles of X, and we end up with 12 grams per mole. And who is that? Well, that would be carbon. So X is equal to carbon. Now this one asks you to balance the equation. So pause the video first and balance it. Welcome back. There you go, carbon, hydrogen, and oxygen. Start with what you have underneath each one of these substances so you know where you're going. So we have propane, 15.23 grams of this, and I need grams of oxygen. Well, to do that, you're going to have to go through moles, over to moles, because that's the connector from one substance to another. You have to go through moles and then to grams. So start with what you have, chase that unit down. Now we're going to, don't forget, chase this unit down, and grams to mole is always 1 mole. Don't forget that part. And the balanced equation says 1 mole of propane is equal to 5 moles of oxygen. And 1 mole of oxygen contains 32 grams of oxygen. A lot of kids want to put 16 there, so be careful. You have to use the molar mass of O2. Make sure your sig figs are correct, and you're done. These next several slides cover the same question. So we need a synthesis of water. Remember, synthesis means you start with elements, and then you go to your product. So the product is water. What 2 elements go into making water? Well, that's hydrogen and oxygen. So there's your balanced chemical equation. Elements, not ions, elements. Now we need to, now that we have the balanced chemical equation, we need to figure out who we're going to run out of first. So we have 2 hydrogens plus 1 oxygen yields 2 waters. So here we go. The little guy is always hydrogen because hydrogen's small. So we have this hydrogen, and this oxygen, and we make 2 waters with those. So 2 little Mickey Mouses would be good. Now we're going to do it again. And 2 more little Mickey Mouses. And 2 more. If only I could speed up this process. This one, for this one, makes 2 more. And don't forget, we need leftover reactant. So that means these guys have to be drawn as our leftover reactant. Keep them together because that's how they appeared to initially. So the limiting reactant in this case is the one we ran out of first. Well, if you look back on the picture that I don't have anymore, the one we ran out of first was hydrogen. And the next question is, how many molecules of excess reactant were left over? Well, excess, we had these 2 were left over, so we had 2 molecules of O2 left over. Make sure you can do this problem. It's worth a lot of points, and I guarantee there'll be one very similar to this one on the test, for sure. Well, in this case, we have 254 grams of this. We have 25 grams of this, so who's going to make the amount of iron? Which one controls the reaction? Well, that means it's a limiting reactant problem because we have the amounts of both. So the first step is you need to convert these both to moles. And then we're going to do the same thing again for carbon. Convert those to moles. Who's the limiting reactant? Well, you can't tell yet because you have to do a mole ratio to be able to tell. So I like to start with carbon because that number is still in my calculator, but it doesn't matter. And using the mole ratios from the balanced equation, I find I need this many moles of Fe2O3 to make all of the carbon go away. Do I have enough? Yes, I do. That means carbon is your limiting reactant. Since carbon's the limiting reactant, I'm going to start with this one so that I can find grams of iron. That's what we're trying to find. So use your limiting reactant to find grams of iron. According to the balanced equation, you have 3 moles of carbon for every 4 moles of iron, and 1 mole of iron has that many grams of iron, so there's your final product. The next question says, well, if a student only makes 125 grams of iron in the lab, what is the percent yield? Remember, alphabetical, actual over theoretical, times 100. So the actual amount was 125 divided by 155 grams times 100, 80.6% grams. Well, 80.6% is your percent yield of iron. Not too bad. The last question is, how much of each reactant is left over? Well, if you recall, the carbon was our limiting reactant, which means I don't have any of that left. That's easy. Easy answer, 0 grams of carbon. Use your limiting reactant to figure out how much of the Fe2O3 you actually used in this reaction. So I know I used 3 moles of carbon for every 2 moles, and I can convert that to grams. Well, that's how many grams we used in this reaction. And we had this much. So how are we going to finish it? Well, then you just subtract it. Make sure your sig figs are good and you're done. Good luck on your test.